Welcome to The Explainer. Today, we are diving straight into a massive, frankly fascinating shift in technology. We're decoding the monumental leap from simple chatbots to autonomous AI agents acting as our new digital workforce. If you've been paying attention to the tech space lately, you've absolutely heard the hype. 2025 is the year of the AI agent. But what does that actually mean? Let's figure out what it looks like to move past basic conversational AI into a world where digital entities actually do the heavy lifting for us, and honestly, how this is going to completely reshape your daily workflows. So, ask yourselves this question as we dive in. If we're the ones architecting this future, who, or rather what, are we actually hiring? We keep hearing these breathless declarations that entire jobs are literally being automated overnight. But we need to look right past all that hype to understand the actual underlying mechanics. How smart are these systems really? Let's find out together.
Because here is the massive leap we're making. Think about a standard generative AI chatbot. At its core, it's fundamentally passive. It's a highly sophisticated pattern matching machine, sure, but it just sits there, waiting, doing absolute nothing until you give it a prompt. An agentic system, though, it's completely different. It maintains a state, it's proactive. It actually thinks, it breaks down complex goals into subtasks, grabs the tools it needs, checks its own work, and even adjusts its plan based on feedback. Really? It's the difference between having a static reference encyclopedia sitting on your shelf and an eager, autonomous intern working away right at your desk.
Okay, let's lay out our blueprint for this explainer. We're covering 1. Chatbots to autonomous agents. 2. The 5 agent types. 3. Multi-agent design patterns. 4. Real-world agent use cases. 5. Surviving the dumb zone. And finally, 6. The human in the loop.
Starting with Section 1, Chatbots to autonomous agents. Let's trace the evolutionary path of this tech.
Notice how we move from a passive LLM to a rigid workflow, and finally to a true agent. At level 1, we ask a chatbot a question, and it simply answers. Easy. At level 2, we build an AI workflow. Maybe we tell the system, hey, always check my Google Calendar before answering an email. But that level 2 workflow ultimately falls short because it's still a rigid, predefined path hard-coded by a human. If it hits a surprise, it just breaks. Now level 3, that's where the magic happens. The AI itself becomes the core decision maker. It dynamically routes its own tasks and figures out the most efficient way to achieve a goal, completely on its own.
Section 2, the 5 agent types. Let's get to know the resumes of your new digital team.
So, the absolutely crucial thing to understand for your business is that not all agents are created equal. They range from super basic rule followers to incredibly complex adapters. Let's walk through them. First, you have a simple reflex agent. It operates purely on if-then rules, like a smart thermostat. Step it up a notch, and a model-based agent adds memory. Think of a robotic vacuum tracking exactly which rooms it's already cleaned. Next, a goal-based agent simulates the future to reach a destination, kind of like a self-driving car navigating through traffic. Then, a utility-based agent doesn't just reach the goal, it optimizes for the absolute best route, like a delivery drone optimizing battery life in midair. And finally, the holy grail, the learning agent. Imagine a chess spot that gets utterly destroyed in a game, but then instantly updates its own core logic based on that failure, so it never ever makes that same mistake again. That is the pinnacle of adaptability.
Moving right along to Section 3, multi-agent design patterns. How do we organize these individual specialists into a functioning team?
Well, before they even team up, every single agent relies on the React framework to basically pause, think, and use tools. React stands for reasoning and acting, and honestly, it is the true engine of agency. It is a continuous loop. The agent observes its environment, reasons about the best approach, takes an action by calling an external tool, like say opening a spreadsheet or searching the web. It observes the result of that action and then loops right back to reasoning until the job is totally done.
Now, when we start building these multi-agent teams, we have distinct architectural choices, and the one you pick fundamentally changes how your workflow operates. A sequential pattern runs agents one right after the other. It's a predictable assembly line, which is great for structured tasks, like writing a report and then passing it to an editor. But parallel routing sends agents out simultaneously. It's lightning fast, drastically cutting down wait times, but it's way more complex and expensive to run. Alternatively, you can use a supervisor pattern. This is where you deploy a manager agent whose sole job is to route tasks to sub-agents, acting as a true digital middle manager.
And to keep these digital teams from rambling completely off topic, we use strict code contracts. If you're building automated business workflows, you absolutely cannot have a reviewing agent replying with, well, it depends, or writing you a 3-paragraph essay. you need hard, reliable data. So, by using Pydantic schemas, which are basically strict data formatting rules in Python, we literally force the AI to return exactly what we need, like a hard pass or fail. It applies type safety to the AI's output, essentially turning a chatty conversational bot into a perfectly reliable, predictable microservice.
Section 4. Real-world agent use cases. Let's step out of the theoretical for a sec and see this in action.
It is truly incredible to see how this technology can quite literally save lives. Imagine a disaster response scenario right after an earthquake. No single human can monitor everything at once, but a multi-agent system absolutely can. 1 minute post-quake, a coordinator planner agent sets the goal. By minute 5, specialist agents kick into high gear in parallel. One is scanning live satellite imagery for collapsed structures, while another is simultaneously parsing thousands of local social media posts for distress signals. They feed all this into a shared memory map. By minute 10, an executor agent is dynamically routing fire trucks and ambulances. That is a multi-agent workflow providing massive, tangible, real-world benefits.
On to Section 5. Surviving the dumb zone. We need to talk about avoiding AI pitfalls.
Because here's the hidden danger with these systems. If you push an AI too hard, it fundamentally breaks down. To understand why, we need to know what tokens are. Think of tokens as the puzzle pieces of words an AI holds in its active memory. Past roughly 100,000 tokens, the AI's attention just strains. It's exactly like a human trying to juggle too many plates. The AI starts dropping things, entering what we call the dumb zone, and it starts making really stupid decisions. You want to keep them in that pristine, smart zone. So to get the absolute best work out of your AI workforce, you must size their tasks down to fit entirely within that highly capable zone.
So how do we keep tasks small and stay in that smart zone? Well, AI naturally loves to work horizontally. It wants to build the entire database layer first, then the whole API layer, and then the front end. Think of it like stacking messy pancakes layer by layer. But the problem is, you don't find out if the whole stack actually works until the very end. Instead, we have to force our agents to build vertical slices using tracer bullets. Think of this like taking a clean slice of cake right down the middle, building thin, fully functional features spanning from the database all the way up to the user interface. This creates instant feedback loops, ensuring that if something breaks, we know about it immediately.
Which brings us to Section 6, the human in the loop. Let's navigate our own evolving role here. Because if agents are doing all the typing, what exactly are we doing? Well, one of the biggest mistakes people make is throwing a vague spec sheet at an AI and just hoping for the best. Instead, try this. It's a real light bulb moment. Prompt the AI to interview you. Force it to ask you questions relentlessly until you both have a crystal clear shared design concept. This alignment phase guarantees you are on exactly the same page before a single line of code is ever written. It stops misalignment dead in its tracks.
I like to think of our new partnership as a strict shift schedule. We do the high-level day shift. Our job is moving firmly away from manual typing and toward deep planning, architectural grilling, and quality assurance. We set up the Kanban board, we define the goals, we ensure alignment, and then we step away. The AI works the night shift. It autonomously churns through tasks, writing the code and executing while we are AFK, literally away from keyboard. We guide the vision, the agents do the heavy lifting. But to effectively manage that night shift, we really need a secret weapon, and that is test-driven development. You see, an AI agent working autonomously is basically coding blind, so it desperately needs automated guardrails. By forcing the agent to write a failing test first, then using its tools to build the code to fix it, and finally watching that test pass, it creates this continuous automated reality check. Honestly, this single practice is what turns chaotic AI output into a highly reliable, production-ready codebase.
So I'm going to leave you with this to ponder. As AI agents increasingly take over the manual typing, how will your unique human taste and your vision shape the battleground of tomorrow's code? The basic mechanics of executing workflows are absolutely being automated, but the overarching architecture, the taste, and the human intuition of what actually provides value to people, that is strictly your domain. Master how to manage this new autonomous workforce, and there is literally no limit to what you can build. Thanks for joining me on this explainer. Let's keep exploring, and I'll catch you on the next one.